So, nika-return ako sa inyong papers. Please tell me if nasakto rag check kay para ma-revise na ko ang midterm mga grades, no? Okay? Sige, mag-check sa kong attendance please. Sige, please turn on your cameras. Murag kamoy lang kita ron. Sige, ayaw lang i-turn off, no? Kay boring kayo. Huwag kong makitaan. Sige, kana lang. Karin, Alferez, Arnado, Bertolata, Buntuyan, Botilla, Cabajo, Palaran, Claire, Bisabella, De La Serna, Sicarino, Enot, Gore, Lisa, Laguna, Oliva, Patigayon. Okay, sige. Class Mayor, please na kukuhan ha sa attendance ha. Sige, ayaw lang i-close yung cameras kaya para na kayo makita, no? Sige. Thank you. By the way, sa midterm exam, highest score is 46. So, that's Mr. Solon Christian. So, highest, no? So, 46. Okay? So, ang uban is 42. So, most of you, talaga nagkakog 42, but dito rin ginasango sa terms, no? So, understandable, no? But again, happy ko kay ang problems at least nakuha na tanan. Okay ra. Meaning, nakuha na day. So, sa terms lang siguro nasango. Okay? So, overall class, inyong midterm exam results kay okay ra so far. So far, okay ra good eh. Now, karon is start naman sa itong midterm. So, mo na lang yung last, no? Muna ta. So, if feel ninyo nagkalisod mo sa prelim o sa midterms, please, hinahinay naman, no? Pamundo ba? Okay, so next week, I will be giving you your kaning papers o sa inyong midterm grade, no? Okay, para na may mga reklamo, then you can approach me. Sige, so ako sa i-share ang ano, answer key sa exam. Kita ra class? Hello? Kita ra ang kwan? Answer key?
Yes, sir.
Okay, so let us start. So this one, situation 1 and 2. The regular wedge of wood having SPGR 0.6 is forced into the water by a 10 Newton force. So how do we solve this problem? So again, BF is equals to W. Diba? Maura gini siya sa inani nga types of problems. Now for BF, we have 9.81 times 1/2 times X times D times 1. So if sa ng X, this is our X. No? Dili man na constant ang X kay ni taper man na siya. Diba? And then this is our D. Kani siya. Kadali lang ha, kani mo join sa ko. Wala man. Sige na. So, kana no? Itong X of B, itong W is 0.6 times 9.81 times 1/2 3 times 4. No? So again, pinaka-importante there is how do we get X? By ratio and proportion. So by ratio and proportion, we can say nga dako taon na no? 4/3. Again, given ni siya is equals to D over X. Then, kuha na tong X as 3/4 T. Okay? After getting, substitute rin na ito din. We get our D as this one. 3.1 meters. Okay, so some of you might have different solutions, but fail ako muna sa pinakadali, no? So lang ratio and proportion, makuha na nimo. Okay, now what value of force must be added? So value of force must be added, so atong equation now becomes BF W plus F. Parang ma-fully submerged yan. Owning naman ni F din eh. No? So pila yung force kailangan para ma-fully submerged siya. So again, we just write the same equation kani siya. So atong equation now becomes 9.81 times 1 half times 3 times 4 times 1 0.6 9.81 so ganito 1 half 3 4 plus F. Then we get our F as this one. Okay, so I hope nag-gets na. Now let's move on to the next situation. Cylindrical tank. Now again class, wala gi-state here no if open or closed, but if you take a look at the given questions, na may giingon diri nga remaining volume was 3/4 of the initial volume. So dira pa lang panahon na ka nga nagyoy na yabo, di ba? Nagyoy na bilin nga 3/4, so na yabo. So kay na yabo, it is an open cylindrical tank. Oh, dili man na may tabo nga mas fill if closed, di ba? So sa problem parang daan, makakuha na ka nga open siya. Okay? So number 3, we are to determine the angular velocity of the tank. Ang mabilin sa volume is 3/4 na lang sa initial volume. So dili naman ako isuwat ang mga figures. So let's have this one. Volume initial, this is just the volume of the cylinder, pi 6 squared times 4.8. I believe this is 5.43. So V final, this is just 3/4 of this one. It's equal to 4.0725. No, that is in cubic meters. Now, volume of our paraboloid is just equal to the volume spilled. Siyempre, nagyo na spill, no? Kaya nagyo, 3/4 na nagyo na nabilin. Okay? So, how do we get volume spill? Minus running doa. No, initial minus left is more na above. Okay, so 5.43 minus 4 point something is equals to 1.3575. No, 3575. Now again, this is just the volume of the parabola. So we can say this one, 1/2 pi r squared h is equals to, siya, 1.3575. No? Given maning r, ang h na lang ito kay taon. Solving for h, we get 1.3575. Now, na naman tayo h, makuha natin natin using this formula. Omega squared r squared over g. No? We can get omega dayon as 109 RPM. Letter A. Okay. Kasi, pwede ba may erase, no? Erase. Sige. Now, this one, angular velocity, so that the pressure at the center of the base of the tank is 0 kPa. So again, if pressure at the base, we take the height as the height of the cylinder. So, pila gani ang omega, no? This is 154 something. Kani siya. Okay, now third one. The tank is brought to rest. What will be the remaining height of the water? So 2.401 meters. So again class, may nangutan natin if consider katong nagtuyok ba, katong initial, etc. So, ay class, irrelevant siya, no? So, ang importante na is puro to rest. Meaning, sa gituyok. So, we can say volume parabola is equal to the volume speed, where the volume of the parabola is just 1/2 pi r squared h. No? Given naman inaaman ni tanan, so this is 2.714 cubic meters. The volume final is just equal to volume initial minus the volume paraboloid with the volume speed. So, volume initial, nakuha man niya 5.44 minus 2.714. Answer niya is pila 0.716. Okay. So, this one, equating it to the volume of the cylinder, finding H, we have 2.401. Okay, remaining height of the water man. Okay, let's move on to situation number 3. So, situation number 3, closed cylindrical vessel. So, muna yung answers. Again, class, di na na-question ang solution direct kay medyo taas-taas yan, no? So, answer is B, C, C for situation 3. So, you can find the solution in the reviewer. So, narani siya. So, ako na nang gikuha dito. So, importante yan niya, class, is how do we get the pressure? 0 the depth of water. So, again, ang depth of water is katong H. Di ba natin formula H is equals to H squared over sa kato siya. Okay, and then if we set our omega to 20 radians per second, how much area of the bottom is uncovered? So, kanin siya. Now, discuss sa terms. Volume of fluid passing a cross-section of a stream is discharge. Okay, so again, class, ang keyword there is unit time. No? So, when we say unit time, rate ta siya. So, kung sa may unit sa velocity, velocity is sa unit sa velocity, class.
Meters per second, sir.
Meters per second. So, sayop na siya daan, no? Kaya gisulti man niya volume. Di man ni volume. So, wrong na niya. No? Maratag flow. What is flow? Kamang flow. Again lahi na ang flow. Lahi mo na ang flow rate. Flow rate is the same as discharge. Pareho na sila. Muna siya. Okay, so again, class, ang answer dito is discharge, no? Volume over time. Now, this one, the flow is said to be turbulent, where the path of the individual particles are irregular and continuously cross each other. Okay, so this morning atong discuss noon sa mga types of flows. So, maratag laminar, no? Like turbulent, ikis-ikis yung path, no? Say turbulent flow. Okay. Let's move on to this one. Situation 4. Dili po na ko i-show ang solution na nino kay direct substitution na ni siya. So, water flows through 100 mm pipe at a velocity of 5 meters per second. So, I don't know if diri ba ito nga section, but napinungutanan ako, sir, unsa din 100 meters length ni siya, 100 mm. So, in ana class is common sense po na, no? Di ka kitag 100 mm nga length sa pipe, no? So, diameter gina siya. No? So, man ang 100, pwede gamaya na nga pipe, mga ana nakatas, Okay? So, dili sa tanang panahon, ihatag sa examiner, no, ang kuan gyud every detail sa problem. So, this one, volume flow rate. Unsay formula sa volume flow rate? Yes?
Area times velocity.
No, so volume flow rate is just Q, no? AV. Ang ato na lang din is converted into liters per second. So how do we compute m cubed to liters per second? Multiply na ito 1,000, no? Kay 1 m cubed is equals to 1,000 liters man. Okay, so makuha siguro nila sa mga point something 39, and then times ito 1,000, we get 39 liters per second. Okay. How about mass flow rate? Formula sa mass flow rate.
Here times density.
Ano to? Mass flow rate is?
Density times Q, sir.
Okay, density times Q, no? So, kana siya. So, dito ra gyapon direct substitution ra ato na is convert into pounds, no? Okay, convert or depende sa inyong gamiton nga density sa water, no? O kamo na kipawan na. So, direct sub naman na siya. How about with flow rate? I believe nasayo kog hatag sa notes ani, no? Sayo pang nabutang nito. So, weight flow rate is
Specific weight times Q.
Weight or Q, no? Or you could also use rho G times Q. Okay, so muna siya, no? So, direct substitution na gyapon. So, you will get kana siya 32.59. Okay. This one, 14. Flow is said to be laminar if it is less than 2,100. Okay, device used to measure pressure heads in pipes where the liquid is in motion, piezometer. Okay, so kaning barometer katong maning sa atmospheric, no, pressure. Manometer is katong mga what's this? Katurang itao da ditso ba? One famous type of manometer is the YouTube manometer. Katong sa gigisolve, no? Ito tube, for example na kay moving fluid, mura na sa L shape. Measure sa stagnation pressure. Sige lang. Later on, regarding sa fluid flow in pipes, atong ma-discuss ang kaning piezometer o ang kaning pito tube. Okay. So, this one. Situation number 5. Gas flows by conduit as shown. So again, class, number 16, where to determine the mass flow rate. So again, how do we solve this one? Mass flow rate at section 2. So, simply, class, continuity mo tani. Or you can say rho 1, A1, B1, rho 2, A2, B2. No, syempre, kay given mo tag different densities. Okay, but we know nga kani siya, this is M2. So to get M2, we just need to get this one. Then given naman natanan, di ba? So direct sub ra gyapon, we get this one. Okay. Next is the mass density at section 2. Mass density. So again, rearranging the formula, we are asked to find P2, density 2 man. Simply rho 1, A1, B1 over A2, B2. No? So we get density 2 as 1.76. Okay. Next, kanya po, situation 6. I believe same lagi po, no? Same ra siya. So, velocity at section 1. Continuity hipunta. A1, A1, A2, B2. So, again, how do we get area 1? Pi over 4 D1 squared gipon V1. But moment itong ipa-find kung takibawan ni. Okay? But kanisiya. So therefore, pwede na itong ato equation mo siyang V1 is equals to D2 over D1 squared times V2. No? Given mo ng V2 nga 5. Therefore, we get V1 as 11.25. Again, class, direct sub lagi po na siya. Volume flow rate at section 1. So, volume flow rate, again, this is just Q equals to AV. So, direct sub lagi po. So, kibaw naman ka sa velocity at 1. So, multiply na rin yung area. We get 0.795. Okay? Ano pa rin last? Volume flow rate at section 2. So, this is just the same. Again, by principle, Q1 is equals to Q2. Ano ganun siya? Because fluids are generally incompressible. So, kung mga incompressible fluid, wala changes sa yung density. Kaya di ba, if we compress a fluid, mas makusog or mas padako ang yung density, no? So, muna siya. So, same record siya by virtue of continuity. But, if kailangan nyo na ito i-prove mathematically, so we can say U2. So, area 2 is just 5 over 4. 0.3 squared times 5. Ito ba? 5 ba ni? Ay, 0.45 din eh. Sa 2 naman dito. 0.45 times 5. Okay, no? And I believe atong Q2 magawas is kanina po. Now, the weight flow rate. Weight flow rate is just this one. Or, again, you can use this one. So, mas ganahan ko kanina gamiton. So, this one is just density times 9.81 times 0.795. We get this one. The mass flow rate, again, density Q, kuha tayo po namin. Okay? So, wala siya. So, now, more terms. Oh, so, sayang kayo if hindi makuha terms. Which of the following statements is incorrect? So, letter A. No? Reynolds number is the ratio. Ang sakto niya is ratio of inertial over viscous forces. No, ako na nang bali. So, Bernoulli's equation holds true on the streamline. So, this is correct. So, ato na ni siya discuss later on. For fluids at rest, the pressure is equal in any direction by virtue of, so ganun siya? So, man siya? Limot na mo? Okay, class, din manigi ka ng letter C. This is by virtue of Pascal's law. No, sige, kung balik, ay lagi naman pala sa Pascal, no? Pascal's law. Mo bining reason nga nung katong nag-YouTube manometer ta makakata-cross ta kay equal ang pressure diri og diri. Di ba? Sige, mitag balik-balik ni Pascal, no? Okay, mo na siya say mag-pressure diri. Okay? This one, steady flow does not change with time at any point. No? So by definition, steady flow does not change with time at any point. So you can say change in velocity with respect to time is 0 for steady flows. Kung mayroon kag uniform flows, partial derivative of velocity with respect to a certain distance or length for s is equals to 0. Okay? So, sige lang, ito na siyang discuss later on. 24. Origin of the energy conservation used in flow systems. This is the first law of thermodynamics. So, may state na yung first law of thermodynamics in a class? Famous kini siya class, first law of thermodynamics. It states nga energy cannot be created nor destroyed, or matter cannot be created nor destroyed, no? Ano siya? Conservation of mass and energy. Muna siya. Ganito, energy conservation, meaning wala siyang ma-destroy ang energy. It is just converted into another shape or form. No? Last, 25. Average velocity is cross-section the same in any length or reach of a stream. We have uniform. Okay, so please review and then check, no, if kanabana mo, if asa mo na wrong. So next week, I will be giving you your papers. So, or if ganahan mo makakita po sa inyong papers, if mo ninyo class mayor, so just PM me sa group chat, no, kay para akong mahatag niyo sa gawas. No, kaya sa ganahan mo si gunit tagagpapil good. Okay? So, muna siya.
Excuse me, sir. I-upload ra na mo sa class, sir.
Dili na ko i-upload. Kay, again, naiuban nga dili mo tunga sa klase, magpalit-lit, so ilaan na sa, no? Or sa uban, wala nag-notes, like wala na mino, so ilahan na. No, din ako mag-remind class kay final sa ta. Okay? I believe po, generally, no, sa'yo na gito nga exam. No, so if ever nag-subsolve mo or nag-answer mo, so sa'yo na gito. Ana, perfect gani siguro mo. Sango lagi siguro sa terms, no? Sige, ako sa i-share ang kuan ha. Presentation. Makita na ang presentation class.
Yes, sir.
Okay, thank you. So today we'll be discussing about fundamentals of fluid flow. So although naka-study na mo ani, so better, no? Kaya at least mas nakasabot na mo. So fluid flow, this is just the motion of a fluid when subjected to different unbalanced forces. No, syempre unbalanced good, if balanced, di sa malihok. No? This just deals with fluid dynamics. So again, a branch, no, of fluid mechanics. So generally class, dagan gigitag types of flow, no, or fluid flow. So ako lang gibutang din ka ng mga main, you know, o basic yun kayo touch. So we have the steady or unsteady flow. We also have the uniform or the non-uniform flows. Okay. So may nakalaya sa steady versus unsteady flow. So again, the keyword here is just a change in velocity, pressure, density with respect to time. No? So can you see a change in V with respect to time is equals to 0. Change in pressure with respect to time is 0, or change in pressure with respect to time is 0, or napayuban, change this discharge or flow rate with respect to time is 0. No? Mauna siya. Okay? So, para mas dali nyo ma-imagine class, ma-differentiate ang steady versus uniform, etc. Muna kag steady, example, magdagan mong bike. So, di ba steady, gani meaning, wala nagkakusog, wala nagkahinay, no? So, steady na gid siya. Muna gani yung dagat. No? So, that is a steady flow. So, when we say unsteady, syempre, dili na siya equal to 0. No? So, meaning the velocity changes with time. or the pressure changes with time, or the density changes with time. Okay, mura na siya class. For uniform and non-uniform, so again, kung mong imagine nun, when tag-uniform, limpyo kasi agnaw ba? Ano yun, no? Well, if non-uniform, yun ani siya. So may nakalahi, again, does not change with respect to a certain distance, no, or length. That is why in this case, we use the variable s, no, to indicate distance. No, so meaning the velocity does not change with a specific length, so equals to 0. Again, when we say non-uniform, kasi trapod. So mag-change siya with a specific length. So pareha ni class, syempre, natay V1, natay V2 dire. Again, kay if one i-compress, makusog ang ginang agas dira, di ba? Example, gunit kag hose, agas kag tubig, if one pisiliton dira, kusog ginang agas no sa hose. Diba? Kaya magmubuo at tubig ba? Okay. So, steady flows and unsteady flows can be either uniform or non-uniform, no? So, kung yung steady uniform, kani siya, steady yung flow, uniform na po ang iyang cross-section. When we say non-uniform, kani siya class, steady yung flow, but ni taper siya later on. So, may mo ng non-uniform yung flow. Okay? Now, for unsteady flow, uniform siya, but dili siya steady, no? Mag-change yung velocity with respect to time. While for non-uniform, again, class ni taper siya, dili ipon siya steady. No? Nag-change ang iyang velocity with respect to time. Okay? Now, let's go to laminar and turbulent flow. So, nabali nila akong picture class. So, this is laminar. This one is the turbulent. No, laminar flow is when the adjacent layers do not cross each other, no? Or it moves along a well-defined path. Example here is the flow sa to mga ugat, no? So, well-defined path, yun na. So, if ever, dili na sa move in a well-defined path, okay ba sa metabo na, high blood siguro, matakihon, siguro, no? But basically, mauna siya. When we say turbulent flow, adjacent layers cross each other. No, does not move along a well-defined path. In this case, a turbulent flow kani siya. No? So, general examples kay flows to a river or canal or smoke from a chimney. No? In the cases sa kanang mga gas. Also have compressible and incompressible flows. No? So, question class, is water compressible or incompressible?
Compressible, sir.
Compressible, okay? Yan naman. I mean, ganun, kaingon man nga compressible ang tubig. So, kani class, if you take a syringe, no, or kanang injection ba, butangan na ninyo tubig dira, hindi naman na dira, no? Tabunan ninyo sing fingers, i-try ninyo compress ang tubig diri. Compress ba ninyo?
Dili, sir.
So, generally class, ang liquids good is plain water is treated as non-compressible fluids, no? So, mga water mo sa di sa compressible. So, unlike if gas na ang nadira, so if you mo na siyang i-plunge, maabot siguro na diri, no? Kana siya. So, mingunta ang gas is much more compressible than liquids. But generally class, for practical purposes, ang liquids or water is treated as an incompressible fluid. Okay? Sige. Kasi, no? So, unsa may difference din between compressible and incompressible fluid. So, kung i-compress na to ang isa ka fluid, mudako ang iyang density. No? So, kung mo na tag incompressible, I mean, compressible, density does not remain constant. Kaya mo dako man yung density if i-compress, no? Moro ba ka na magkumot ng papel, no? Or sa kung sang butanga, no? Dako mo yun ang density. But if the density remains constant for the fluid flow, it is called an incompressible flow. No? There is a figure class incompressible flow. Wala ni change ang density from point 1 to point 2. While sa compressible flow, ma-change ang density, no? From point 1 to point 2. Now, discharge or flow rate. Again, flow rate is just the amount of fluid passing through a section per unit time. No, amount of fluid. This is in liters, no, or cubic meters. So, natin lang expression or forms of flow rate. It could be using the volume, mass, or the weight. So, muna itong mga formulas, no, as discussed. Q equals to AV, M is equals to density times Q, weight flow rate is what's this? Unit weight times Q. So again, ako lang ni-issue, kaya basig na po naglibog, no? So units sa Q, this is cubic meters per second. So AV, area is M squared. Velocity is meters per second. Oh, so mo na siya, equal siya, no? So for mass flow rate, ang unit ano niya is kg per second. This is equal to density is kg per m cube times m cube per second on q. Cancel, we are left with kg per second. For weight, we have newtons or kn per second. Palimutan kn. So unit weight is kn per m cube times m cube per second. So maunang natay kn per second. Again, same mo na tanong nun, lain lang ang pagka-express. Okay? Let's talk about the continuity equation. So, the continuity equation results from the principle of conservation of mass. Again, also meaning sa conservation of mass, meaning kung natay mass nga nag-flow isa ka point, same ka parang mass nga nagawa sa bigas. No? So for a steady flow, the mass of fluid passing all sections in a stream of fluid per unit time is just the same. Wala gitawag continuity, meaning kung sa inisod, maura po inikawas. Okay? So for compressible fluids, we have here is one, no? As you notice, compressible is usab yung density. No? Nata density 1, nata density 2. Diri is 2 din sa class, no? So, nasa iyo ako. So, for incompressible fluid, same ra. Di man ma-change. Wa may change. So, mahog na mag-cancel na siya. So, dito rin siya Q, or A1, V1, A2, V2. Okay? Mura na siya. Let's talk about energy and head. No? So, energy daw class is defined as the ability to do work. Now, my question is, what is work? What is work, man class? Hello? Sama na work. Trabaho. Sama na. Trabaho. Sama na. Hello? Class, nanapin na yung pag-elementary na to, no? Kaning energy, mga work. No, napanipag high school. Ako ni siguro sa inyong senior high, no? So maning work.
Cancer, ang work kay ang work kay ang energy ang work sa kay ang energy na ma-transfer if na object na i-move from a certain distance.
energy, ang working energy nga ma-transfer if ma-move certain distance. Okay? Thank you. So, natay lang answer. Actually, that was correct, no? So, need ko kuan siguro lang answer ka na mas simplify ni answer kay ako ra ba dugay ra ba ko kasabot kaya hindi ko kanang as simple as possible para makasabot.
Sir, pwede ko matry, sir?
Sige.
Ulod, sir. So, ako, sir, sa potential energy na duha ka klase nga energy, which is elevation energy and pressure energy. Sa elevation energy, it is the potential energy possessed by fluid by virtue of possession or elevation with respect to arbitrarily selected atoms. Ang makuha na to na, sir, kaya ang elevation energy nga WZ, which is weight times Z, mo na ang kuha na to sa elevation head nga ang formula na kay mass times gravity times Z. Kaya sa pressure energy kay potential energy possessed by fluid due to pressure. Nga ang
Excuse me sa Mr. Tuluda. I mean, murag advance sa kito da, murag dira pa tapadong, no?
sorry,
But,
sir.
okay ra. Akong question lang is, unsay work? What is work? Work lang yun.
Mathematically, siguro, work is force times distance, which is mao to ang gisulti ni De La Serna.
Okay, yung tag force times distance. So work daw is force times distance. Now, na ako example. For example, magbarog ko no. Stretch na ko ha, fully stretch na kong arm. Magkunit ko basketball dire for 10 hours. Na ko yung work gibuhat or wala?
Wala, sir.
Wala, nganong wala man.
Wala may displacement nga imong mag-apply sa force.
Yes, that is correct, no? So basically, naara ko dira, but wala ko yung work gihimo. Wala mo ko naglihok. Pero kapoy lang yun yung naning buhata. Di sa ko magbuhat o ginani, no? Kapoy lang yun na. But essentially, wala gid ko yung trabaho nga gibuhat. No, igor ko nagbarog dira na pagkapoy sa akong kagalingon, no? So by definition, work is just force or the energy applied at an object to move it at a certain distance, no? Mao nang diri sa second sentence expressed in units of Newton meter. Natay force times distance, no? And 1 Newton meter is just 1 joule, no? I remember po ni class, 1 joule, or kung English units ta, this is 1 foot. Okay? Now, in analyzing fluid flows, natay mga important kay nga forms of energy, no? So, diri na to ni come in ang gisod ni Mr. Tulod. Gisod ni Mr. Tulod. So, we have the potential energy, we have the kinetic, and we have the pressure energy. So, we will discuss each of these, no? Para masabtan na to unsa diri mga energy nga naa sa fluid flow. So, natay figure diri class, natay isa ka pipe. It is raised. Ang ang center niya, center sa flow ng flow diri V. Ang center line niya is at a distance Z from our reference datum. So let's start with potential energy. So potential energy is just determined by multiplying the weight of the element by its distance from the reference datum, in this case Z. So unsa gani definition ni potential energy, class? How do we define potential energy? No, number po ni elementary na to, pag high school. Unsa man kanining potential energy? Wala, balik kita ko na ni science ani. Unsa man to ning ko? Unsa man ning potential energy? For example, la kana siya tawhan na nam gani dako kay potential. So unsa may pasabutan?
Energy at rest, sir.
Yes, no? In its simplest form siguro or simplest term, energy at rest. So meaning, matag potential energy, unang energy nga gipossess sa isa ka object or isa ka particle before pa na siya move, meaning based na sa siyang shape, siyang mass, etc. No? Nana na sa energy daan. If ever move na siya, ma-convert na siya into kinetic energy. So, ari sa ta sa potential. So, potential energy is just the product of the weight times its reference datum Z. So, if you notice class, kung ano itong reference mo, so we can have a reference anywhere. So, butang tag kanya itong i-reference mo. Kanya itong i-reference datum. Pila naman itong Z? 0. Therefore, mahugra nga, wala na tayo work mo. Di ba? No? Kay zero man. Okay? So muna siya for potential energy. Now let's go to kinetic energy. So again, kinetic energy is the energy in motion or the energy of a fluid element due to its velocity. So this is determined by multiplying the mass by the square of the velocity and taking half its product. So I believe this formula is very familiar. No, kana siya. Kinetic energy is just 1/2 mv squared. No? Mass multiplied by the square of the velocity squared and then you divide by 2. Now since we're talking about fluid flows class, let's rewrite this one by rewriting m in terms of weight. No? So therefore our equation, the kinetic energy becomes 1/2 wv squared over g. Okay, let's move on to the final one, pressure energy, also known as the flow energy. This is amount of work required to force the element of fluid across a certain distance against the pressure. So in textbooks, usually ang ginagamit nilang notation is FE, no? Kanda naman tayo PE, which is the potential energy. So this can be evaluated using this equation. No? So this is just the work done, pressure, product of area and its length. No, segment's length, pressure, and its cross-sectional area. Again, class, we can also rewrite this one in terms of velocity. I mean volume, velocity naman volume. Because we know that AD is just volume, no? Area times certain length ba? And we also know that volume is just equal to weight over unit weight. Diba? Kaniba? Unit weight is equal to weight over volume. So, mura na siya, no? So, by rewriting, we get this one. This is now our flow energy or the pressure energy. Okay, so kana siya klase. Ako na nag-simplify equation. Now, let's talk about total energy. So again, ato siya is 3 forms of energy man to. So in order to get the total energy, ato na itong isum up ang tulo. Okay, so we simply add PE, KE, and FE. Therefore, our equation becomes this one. So muna ni siya ang isa ka muna ni siya ang total energy nga nasa, nga nag-flow no sa isa ka pipe system. So total energy. So this one. No? This is our potential. This is our kinetic. This is our pressure energy. So again class, sa kanisiya, this is in energy notation. Now, when we deal with fluid mechanics, tara pa day, where each term of the expression has the units nm or pound-foot. Again kay puros man ni sa energy, di ba? And then kibaw man tang energy mo man unit, no? So kada term ani niya, it's either in nm or lb foot. Okay? Now, when we deal with fluid mechanics class or hydraulics problems, usually expressed na siya in terms of head. If you recall sa tuang prelim, di ba natato yung gitawag na pressure head, no? So energy is often expressed as a head or the amount of energy per unit weight of a fluid. The units of a head are in meters or in feet. No? Kaya mas dali man siya i-measure class kung ato sang in terms of head. Excuse. No? So for example, by continue equation, so nata energy 1 is equals to energy 2. By law of conservation of mass, if we divide both sides by weight, again, the same naman tanan. Kung sa nisod sa dire, same na gyapon sa megawas, di ba? Now, our equation becomes this one in terms of head. Ano na siya? So each term diri class, ako na nang gi-divide og weight. No? So mo na ni siya itong equation in terms of head. We have the Z. This is known as show. This is known as the elevation head. This one V squared over 2G. This is now our velocity head. Pressure over unit weight. This is now the pressure head. Now, if you're familiar, no, katutong itabihan last time, di ba? Unit weight, I mean pressure is equals to unit weight times height. Therefore, atong pressure head is just ni siya. No? If you remember, katong nagsukot-sukot tag piezometer, na siya class. For example, natay sa ka tube dire, I mean pipe dire, naman na fluid flow, no? If mo insert tag piezometer dire, same mo ganyan sa level. Na siya, no? Lain na po nga case if magtakilid na po, magslanting na po na tong pipe or inclined na tong pipe, no? Tatag piezometer dira, no? Lain na po na sa nga case. No, depende sa characteristics itong fluid flow. But basically, class, mao ni siya ha, ato ang equation in terms of head. Okay? Where now, ang units niya in terms of meters or feet na lang. Kaya again, divide mo na to both sides by weight. Okay? Now, nakoy question, class. Example, no, mabubuong tanom. No, inana, tapos mag-host. Nganong ni kusog man ang aga sa tubig dira if itong pislito ng kanang tubig?
Ni gamay man ang area, sir.
Ni gamay ang area. Ang pressure ni Saka o ni gamay?
Ni Saka, sir.
Ni Saka po. Okay? So, no, intuitively lang, dito lang, natugyan mo na ano nga, ni Saka ang pressure, kusog yun ang agas, no? So, let us check if sakto ba nitong ginawa. So, energy equation results from the application of the principle of conservation of energy to flow. No? So, in the direction of the flow, again, in the direction of the flow, it is summarized using this equation. No? So, ay lang sa kayo na, ay lang ka mo ka-intimidate at first, but more na siya. No? So, basically, in terms of head ni siya klasa, so this is the energy at section 1. So, we have here the potential, the kinetic, and the pressure. Energy added. Unsa man nga case kas nga naa kay energy ma-add sa isa ka fluid flow. For example, imong ipasaka ang tubig ka sa first floor pero sa 10th floor. No, need man gyud kag dako nga energy ana to do the work ba, di ba? Need man kag dakong energy para ang tubig masaka sa first floor padung sa 10th floor. So may buhaton nimo. We add energy. How do we add energy? By so ipotong sa tubig pero masaka. Atong i-pump. No? One way to add energy is we use pump. No? So ang pinaka-common class sa mga fluid mechanics problem. So may ganitag energy added, natag i-add na nga pump sa system. Para ba atong i-pump ang tubig pasaka? O di mo kamaingon ato i-pump ang tubig paubos. Kanang udi ka na mingon na i-pump ang tubig paubos, no? Pasaka gina siya. Because i-pump adds energy, no, to the fluid flow. This one, energy lost and energy extracted, usually class sa mga textbooks or equations, usually nila giusaran na sila, no, as the energy or the head lost. For example, kay pipe dire. Unsa may mga loss ka nga na-experience sa fluid flow? Sample lang, just pinaka-common. So may loss ka nga na-experience sa ka pipe. For example, kani nga pipe is 10 billion kilometers long. Maka-assure de ka nga ni flow dire same na gyapon dire. One loss is called the friction loss, no? Losses due to friction. Okay na, may friction ng pipe. No, sa mo tayo magkataas, magkadako ng effect sa friction loss, no? So mo na siya. So di kita ka consider na I mean, di kita ka neglect, no, sa losses in pipes. Okay, then we have the energy at section 2. Mo na siya class, no? Mo na ang atuang energy equation. Now let's move on to Bernoulli's equation or principle. So matod pa ni Bernoulli, the total energy in a steadily flowing fluid system is constant along the flow path. So niingon siya nga an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. So matod pa ni Bernoulli, matataan nga figure, kung mo-increase daw ang speed sa fluid, kung siya may tabo sa pressure, salit may erase ha. Kani dire ako lay butang dire kay di ba? Obviously dire mas kusog man gyud ang velocity, no? So if makusog daw ang velocity sa fluid flow, kung siya may tabo sa pressure,
Or decrease.
mo decrease. Dire pod class, hinay man ang velocity dire. So what would happen to the pressure?
Increase.
Vice versa, no? Increase. Therefore, matod pa ni Bernoulli class, if na daw tay increase in velocity, mo gamay daw ang pressure. Pero if mo decrease ang velocity, mo increase ang pressure. Now, as you can see, natin mga piezometers dire, tanaw ninyo, hinay ang velocity dire, mo saka kay ang pressure. No? Natay dire, kusog ang velocity, but gamay ang pressure. Now, to answer the question ganyan, sa katong sa hose, if mo increase ba ang pressure, the answer is, ni-decrease di ang pressure. Kung saan pa di ang pasabot sa pressure ani ni Bernoulli? Ang pasabot niya sa pressure is ang pressure exerted sa walls. Ha? Para dili maglibog ka, pressure exerted sa walls. So, manatag pressure gani class, dire class, dako yung pressure kay dako man yung area. Mas more man sa gi-exert na pressure sa walls, no? The fluid, walang dire is, gamay sa gi-exert nga pressure sa walls sa fluid flow. I mean sa pipe, no? Okay? So, muna si Bernoulli's equation now. Hindi to tani, no? If nagyutay ka ng itong hydraulics ng mga machine, bakit makita yun na to, no? So, at first class, naglibog, lisod si Sabton ba kay counterintuitive bitaw kayo, like ato sa hose. Paggamay na to, magkusog mong gining pressure, ani? Like nana ba? So, it turns out, di ay, no? So, here are some assumptions class about the Bernoulli's equation. So first, it is a steady state. Again, when you say steady state, dili mo change in velocity with respect to time. No energy accumulation. Constant density flow. So when you say constant density flow, assumption is incompressible siya. No, kasi same density all throughout. Temperature is constant across each section. So temperature class is ari na ni siya mas mo take effect, no, if atong fluid kay gas. No? So usually ma-apply na ni siya sa mga thermodynamics, no. Number 4, as one inlet and one outlet. Okay, so mo ni sa mga basic na assumption sa Bernoulli's equation. So natay duha ka important nga mga terms nga yung duman. We have the energy grade line, also known as the EGL. Also have the hydraulic grade line or the HGL. So both of these are just graphical representations, no, sa energy sa atong flow. Again, class, these are just graphical representations, no, the total energy of the flow. Asa man ni sa gikan nga representation. So kani siya class, gibasihan ni siya, for example, sige lang, nako'y video later on, no? But for example, nakay pipe dire. And then mag-install barong kag piezometer. Napo kay pipe tube. Pipe tube is monom sa L shape. No? Sayang ba kay di ta ka-experience ani no. So ito tube wala siya. So again, piezometer is just this one. Same level. So this is what we call our hydraulic grade line. This one is mabasa sa pito tube. This one is our energy grade line. No? Again ha, general laki na nga kuan, rough laki na siya. Basta kita, kagets lang mo sa idea ba nganong graphical representation siya. Okay? Sige lang, nare video later on nga maka-aid na to, no? So we have the energy grade line. So the energy grade line is a graphical representation of the total energy of the flow. So its distance from the datum plane is this one. Velocity head, pressure head, and the elevation head. So unsay characteristics ay sa ka-EGL? This slopes downward in the direction of the flow and will only rise in the presence of the pump. Ngano mo rise ganito siya class kay natay energy gi-add. Okay, if natay energy gi-add, meaning mo rise gyud siya. If ever gani mo drop ang EGL between 2 points, therefore na loss na experience, no? No, that is also what we call as a head loss between 2 points. For a uniform pipe cross section, HGL is simply parallel to EGL. Ang EGL class is permi guna siya na babaw sa HGL, no? By an amount equal to the velocity head at the section. Why? Because now ari na pa sa hydraulic grade line. So distance niya from the datum plane is just this one. Therefore, ang difference nila, ang different, di ba? Ang energy grade line mo ni. The HGL is this one. So ang difference ano nila is just the velocity head, which is V squared over 2G. Okay, again, this also slopes downward in the direction of the flow. For uniform pipe cross section, parallel na sila, and it lies below the energy line by an amount equal to the velocity head at this section. Okay, now this one class, ano siya? Again, HGL is just the sum of the elevation head and the pressure head. So HGL, elevation head plus the pressure head. Can I see? When we say EGL, this is the sum of the tanan, no? Including nasa velocity head. Okay, class, this is just the graphical representation, no? Importante kayo ni siya kay para makibawta kung asa di dapita diri like unsay behavior ba sa tong fluid flow, no? So sa pipe. So kana siya. Okay. Oh, energy equation without head loss. Now again, class, state na dito ganihan no, na if ever gani wala tay losses, straight ra jud atong EGL kay wala mo tay loss. Di ba? Again, balik ta sa itong energy equation. We have energy at point 1 plus HA if naa plus HL, minus HL if naapod is equals to energy at point 2, diba? Mo ni siya. So if ever walay gi-add, walay losses, if cancel na to, therefore straight tayo na to ang energy grade line. No? However, for the hydraulic grade line, kana siya, mo dive na siya, no? Kaya depende man na siya. Again, hydraulic grade line na magbutang tag piezometer dira. So muna siya water level dira. Tag piezometer dira, muna siya reading. Tag piezometer dira, muna reading. No? Muna siya. Okay? So our energy equation becomes this one. No? Kana ra siya. Equal naman siya. Wala man kay mga losses. Okay? For energy equation with loss, so again, head loss is just a drop of energy between any 2 points in the energy grade line. So what is here? Okay? Okay. So muna siya, no? Dili na to straight. Dili na to straight. Kaya na naman tayo losses. Okay? Ano na itong equation class, no? It's for E1, energy 1 minus head loss from points 1 to 2 is equals to E2. So, ato nang transpose dari ang HL1 minus 2. So, mo na ni siya class. This now becomes our equation. Kana siya. No? So, mo na, kamo pohon mag-design mo mga pipe system. So, ayaw ginan nyo kalito yung mga losses, no? Kaya naman na effect sa fluid flow. Okay? Now, this one. Sample problem 1. So, we have to draw the EGL and the hydraulic grade line. So, number 1, EGL, HGL slopes downward the direction of flow. EGL, HGL rises if there's a pump. So, mo ni mga summary. No? So, how do we draw the HGL? So, may drawing sa itong HGL. Ano? Nara. No? Wala mo tayo losses ng experience. Again, class, this is just a graphical representation, but importante is kakuha ta more or less sa general nga behavior sa fluid, no? With the EGL, again, this is just above gini sa HGL, no? Again, without losses, parallel lagi ng duha. Okay? Na wala man tayo state dire nga magkausab-usab yung cross-section. Therefore, constant ang iyang slope. Okay? Now this one, let us try to draw the HGL and the EGL. No? Again, nandito tayo mga basic assumptions dire. Sige, let's try daw. How do we draw the HGL? Again, class, kani siya nga mga assumptions is per section is siya. So, isa ka section, mo na siya. Second na po section. So, basically, class, natay tulo ka, 1, 2, 3. Tulo ka sections diri, no? So, diri, padulong sa pump. Pump, padulong sa turbine. Turbine, padulong sa diri. Nana ba mo idea sa ng turbine, class? Ano mo idea sa ng turbine? Wala. So basically, class, ang turbine is one way of extracting energy. No, so mag-extract ng energy. So example, kana sa mga power plants. So mo nang mogamit tag turbine para ma-extract og energy, no? To convert it into electrical energy. Sige lang. So basically, class, kulay butang diri kung pump ta, pump, add tag energy or add ta sa itong head. Kung mga tag turbine, this is plus, no? This is HE, or you could also say head loss. This is negative. Okay? Sige, so may drawing na to din HGL. So if we try to draw our HGL, and EGL, on na sa inyo. Okay? Again, slopes downward in the direction of the flow. Again, dire man taon na, no? Flow ta padung dire. Pag abot dire, nakasugat man siya pump. Therefore, naiki-add ng energy. So, nisa kata. Okay? And then, flow na punta padulong sa turbine. Pag flow na to padulong sa turbine, nawagtangan pag ito, no? Kaya na mag-extract energy ang turbine. Therefore, slow pag ito downwards. After that, flow na rin yung tatari. Okay, now again, EGL class is just above the HGL. Okay, so again, wala mag-state rin nga difference yung pipe cross-section. Therefore, parallel siya. Kani ba? Now, as you can also see, class, constant ra pud ang iyang sloping, no? Kay again, this one number 5, no? So, mura na siya, class. Again, the difference ani nila is ang velocity head. V squared over 2G. Again, class, visual representations lang ini, ano, para makakibaw ta ba sa behavior. Mura gud siya shear and moment diagram. You can look at it as a shear and moment diagram para kibaw tang mao din ang behavior no sa tuwang beam if mo deflect siya. Mao din ang shear na mao din ang moment nga na, no. You can look at it that way. So, mao na siya. Okay. So, na ko sample video, class. Please tanaw lang niyo, no? So, wala naman po rin sa sounds. So, please watch carefully lang. Ano na lang, class. Mag-send lang kog link ha para I mean ako na play using YouTube para kuan ginin niya. Kita ra, class? Sige, I will now play the video.
To understand the energy and hydraulic grade line, you need the Bernoulli's equation expressed in terms of height. Each term in this equation has a dimension of length, later which is used for visualizing the energy grade lines. Hydraulic grade line can be visualized with a piezometer tube. It measures static pressure by calculating the liquid column height through the center of pipe. If you tap piezometer into several locations and draw the curve through the liquid level, then hydraulic grade line is obtained. Notice, hydraulic grade line just represents the sum of static pressure and the elevation heads. Elevation head depends upon the datum we choose. Now we choose in the center of the pipe, but we can choose anywhere. Now what? If the same pipe is inclined? In this case, change in elevation head will affect the hydraulic grade line. With change in elevation head, results increase in hydraulic grade line. You can imagine hydraulic grade line as potential energy, which is related with Earth's gravity and datum. Energy grade line is the sum of potential and kinetic energy, so it's the total energy of a fluid. In order to visualize kinetic energy, which is related with the velocity of water, we need a pitot tube. Extra height the water column travel is related with the velocity of water, and if you draw the curve, you will get the total energy, also called the energy grade line. The distance between EGL and HGL is the dynamic or velocity head. You can also imagine it as kinetic energy. Okay, now, consider a large tank or reservoir is filled with water. Let us visualize the EGL.
This one, class, this is what we call a venturimeter, huh? Venturimeter.
And HGL of this flowing water. by fitting piezometer at different location and drawing the curve. The black and blue line is also the HGL line. Blue line denotes pressure and black line denotes elevation head, and sum of these two lines is HGL. And the pink one is the velocity head. At point 0, that is, at the liquid surface, EGL and HGL coincide with the liquid surface, since there is no flow or velocity there. In an idealized Bernoulli type flow, EGL is horizontal, and its height is always constant. HGL decreases rapidly as the liquid accelerates into the pipe. The difference between EGL and HGL is velocity head. HGL is the sum of pressure and elevation head. Velocity of water increases at point 2, so HGL decreases, and velocity head increases. Then again along the length of pipe, the HGL increases, as the velocity decreases. You can imagine HGL as the potential energy which is greater than kinetic energy. And the sum of potential and kinetic energy is the total energy or EGL. And finally, HGL decays to the liquid surface at the outlet, since the pressure there is atmospheric, as the pressure head is 0. However, EGL is still higher than HGL by the amount of velocity head. Remember, in real life there is always presence of friction and heat, which decreases the total energy of fluid, so EGL will never be horizontal. Please subscribe for more fluid mechanics.
Okay. So, I hope naka-aid to no ang presentation. So again, class, in reality gid no. So posible gid ka nang walay losses, na gini losses no. So mo nag-ingon nga walay machine no, 100% efficient gid. Okay, so ako sa i-share screen balik. So let's continue. So power, again, this is the rate at which work is done. No? Or you could also say at the rate at which energy is being used. So this is calculated by multiplying the number of newtons or pounds of fluid flowing per second by energy in H in meters or in feet. No? So basically, power is just Y times Q times H. So kung patong i-multiply class using its units, N per MQ, MQ per second, M, we get Newton meter per second, where 1 Newton meter per second is equal to a watt. Okay, now we have here important conversions. We have 1 horsepower, 746 watts. We have 1 horsepower is also equal to 550 pound-foot per second. And we can also say 1 joule is equal to 1 Newton meter per second. No? Or 1 joule is equals to 1 watt. Okay, so important conversions. Now we'll talk about efficiency. So this is just the output over input times 100%. No? So kung pila yung ipagawas, like example sa pump baron, pila output versus sa yung input or yung rated capacity times 100. So ato na ma-check kung unsa gid siya ka-efficient. No? Okay? So pump versus turbine. Magpump og tubig no, I believe kita na mo na. We also have the turbine. So pump is basically a device that moves fluids by a mechanical action. No, this causes a rise in the EGL and HGL by adding energy to the flow. No? Dako yun ang energy kay mo kung gipump. Now for the turbine, it's a rotary mechanical device that extracts energy from fluid flow and converts it into useful work. So may pinaka-famous nga gamit sa turbine kanang mga electric, no? Kanang example sa waterfalls, no? Inana i-convert nila ang energy gikan sa tubig imong kuryente. Mo na ba i-extract niya ang energy, convert niya into useful work. So this causes an abrupt drop in the EGL and HGL by removing energy from the flow. Okay. Now let's have sample problems class. So for the fundamentals of fluid flow, dili na ko maghatag og sample problems katong mga continuity equation. Ikibawon man mo to nag-answer na gud mo sa midterms. Nawari na ta sa kani mga energy and head, no, mo focus. Oil of SPGR 0.75 is flowing through a 150 millimeter pipe under a pressure of 103 kPa. The total energy relative to a datum plane is 2.4 meters below the center of the pipe is 17.9 kN meter per kN. Determine the flow of oil. Sige, ato sa analyze na problem. So, pila may diameter sa pipe? This is 150 millimeters, no? Under a pressure of 103 kPa. The total energy relative to a datum plane. So, may pasabutan ni total energy. Yung total energy, no? Relative to datum plane, 7.4 meters below the center of the pipe. So, kani 2.4 meters, ang saan siya? Hello? So, meaning 2.4 meters below the center of the pipe. Yeah, ito na lang i-solve. So again, class, when we say energy, this is just pressure energy plus kinetic energy plus potential energy. But then again, class, when we solve fluid mechanics problems or hydraulic problems, ato rin saying again express in terms of head, no? Okay, so in terms of head, again, i-state niya diri nga 17.9 is the total energy. Ano na siya? So may pasabutan ng kn m per kn. This is just the head, no? M, ano na siya? Head, di naman na siya m. Again, nga nung nanay over kn. Kaya again, sa kato na itong gi-derive mo, nga gi-divide na to both sides by the weight. No, ako na nag-ibutan nila pag libog-libog pa. But then again, it is just essentially the head. No? Meters yung po nilabas. Ano? So this is the total energy or the head. Okay, now let's get the pressure energy. So again, pressure energy, this is pressure, no? Over the unit weight. Okay, atong isulat para di maglibog. This is just kana plus v squared over 2g plus potential energy. This is just z. Okay. So 17.9 na total. So anti-pressure din 103 over unit weight given matag SPGR. Kani plus v squared over 2g. Kaya ang gipangutana determine the flow of oil man. Next is the potential energy head, which is just equal to the z, no, elevation here from the reference datum. Okay, solving for v, we get 5.426 meters per second. Now, is this our final answer? Dili pa, kaya ang gipangutana is flow man. No, velocity man sa gipangutana is flow man. Now, in textbooks class or in problems, when you're getting flow, usually ang gimina na isang flow rate. Okay? So flow or flow rate na siya. So therefore, natin V, we get the flow rate as Q equals to EV. So this is just 1/4 pi R squared times the V. Therefore, the flow rate is 0.096 cubic meters per second. Sige, class. Any questions? Okay, if no more questions, let's proceed. Second problem. From the figure, water flows from A to B at the rate of 13.2 CFS and the pressure at A is 22.1 feet. Again, so this is pressure, ya tanaw ni mong unit is in terms of feet. Therefore, ang pasabutan niya isang head niya, no? So considering no loss of energy from A to B, again, considering no loss of energy from A to B, find the pressure head at B. So pila daw ang pressure head diri. No? And we are also asked to draw the energy line. So given naman tayo hydraulic grade line, so kay purma sa energy grade line. Okay, so kanay pa lang class. So may drawing na to sa energy grade line na niya. Hello? Okay, class. From this problem, sa kay drawing sa itong energy grade line na niya. Hello? Madungog ko, class? Or sige, anyone who would like to volunteer? Draw lang. Draw lang sa energy grade line. Sa kay, again, no, it may not be an exact yun as long as nakuha lang, no, mo din yung sketch. Mo din yung representation sa energy grade line. Ayaw mo ka-intimidate ang mga values, ang mga araw-araw. Ayaw mo ka-intimidate na class. Tanawan ninyo yung principle, no? Ang behavior sa tubig. Isulti siya considering no loss of energy from A to B. So, sa may noun sa energy grade line na lang.
Same na sa hydraulic grade line.
Same? Okay, good, no? Nice nga naman yan. Sige, unsa kay lahin possible ato nga drawing. Diba, ang hydraulic grade line is morning makuha na itong pressure rate, butang tag, what's this, kaning piezometer. But then, when you take energy grade line, this is the energy good sa system, no? Sa fluid. So, kung mana tag no loss class, straight tayo na siya. Diba? Para sa katong video ba? No? Wala man tayo losses. Therefore, the energy is still the same, no? From point 1 to point 2. Or this case, point A to point B. No? The same na siya. Okay? Although, butang din nga, different siya diameters, but same siya po nang iyahang energy all throughout. Okay? Now, ang ipangutana is, sa to? Find the pressure head at B. Okay, now how do we find the pressure head at B? So again, we use Bernoulli's equation, no? From A to B. Now, diri class sa problem, ang ditong gamit is nasa A, no? So energy at A plus energy added if naa minus energy lost if naa is equals to energy at B. Okay? But since given man niya nga no energy loss, therefore 0 na siya. Okay? So atong equation is makansel ato na 0 mura na siya. Where given ta class atong velocity 1 2 kani sa dire, this is just equal to Q over A. Okay? So this is just 13.2 divided by the area. Pi over 4, 1 squared. So we have 16.8. Excuse. 4, can you see 24 inches. 1/2 squared times 16.8. No, this is just equal to 4.2 feet per second. Now substituting class, pressure head at A is 22.1, can you see plus velocity head 16.8 squared, kanito nakuha, divided by 2G is equal to pressure head at B, velocity head at, what's this, velocity head at B plus the elevation head at B. Okay? No, so again, ang giingon niya diri class, datum is A. So mao nang diri elevation head ni is 0, no? Diri is 15. Okay, kani man siya. So 25 minus 10 is 15. Therefore, the pressure head is 11.2 feet of water. Okay? So again, total energy at any section can be plotted above a chosen datum plane. So again, class, kamo ra gyud magpili no asa ninyo yung datum plane. Pili nyo asa mo mas convenient. So again, computing. So again, if we do it from A, so the energy at A is pressure head A plus velocity head A plus elevation head A. So i-add na nato tanan, we get 36.5 feet. Energy at P is just same like yapon. Pressure plus velocity plus elevation is equal to 36.5 feet. So as you can see, class, energy is conserved. No? Kaya wala may losses. Okay? So ako lang ipakita diri class no nga mao ni siya conservation of energy ba. So E1 is just equal to E2, but ang answer diri is kanina siya. Pressure head at B yung may ipakita. Okay? So sige, tanawa sa problem. Okay. Do you have any questions? Wala? So let us continue. This one. For the 100 mm diameter suction pipe leading to a pump shown in the figure, the pressure at point A in the suction pipe is a vacuum of 180 mm of mercury. If the discharge is 0.03 m3 per second of oil, find the total energy head at point A with respect to a datum at the pump. Direct with respect to a datum at the pump. So kani datum at the pump. Okay. Sige, how are we going to solve this problem? So given tag 100 mm diameter pump, so constant ihang cross section. So given tag discharge 0.03. So we are to get the total energy head at A. So discharge ari sa padung diri ha. Diri ba? Takto ba niya akong orientation class diri? Bali no, dapat saka siya. Alangan gi-pump ko nimo padung babaw. However, diri is gi-suction lang ni siya. Okay? So I hope sabtan ng figure no. Sige, so how do we solve this? So let's start. Energy at A. So we have here the potential, we have here the pressure, the velocity, and the elevation heads. Again, V is equal to Q over A, given maka sa Q, no? So this is equal to 0.03 divided by area, pi r squared over 4. Okay, we have 3.82 meters per second. So this is our velocity. Sa A ni class ha? Now the pressure at A, we have here the unit weight times height. Again ha, pressure at A, this is unit weight times height, which is equal to 13.6 times 9.79 minus 0.180 is equals to 23.97. Now diri class, naisayop diri no. I mean sa textbook is gigamit niya is 79. However, usually atong gamiton lang is 9.81. So please daw ko calculate if we use 9.81. Pila na may tabuan niya. Answer class. Ay, sorry. Na-close mo na eh. Ako ibalik. Ibalik ka. Pare. So this one. Pressure at A is equals to unit weight times height. So ako nang gibutang no using 9.81. We have 24.01 kPa. Now, yun sa man sa pag-compute. Ngano ganing negative 0.180 ni siya kay ngano ganing class? Okay, basta mauna siya. Okay, no? So, 0.180. No, I hope napa mo dira, no? Naminaw pa mo kay wala may muting. Sige, so the energy at A, we have negative 24.01 over 0.85 times 9.81. Okay? So, kani siya. Vacuum of 0.180 mm of mercury. So, mo to siya. Then, given na mo tag-discharge daan. So, ato ni butang lang. energy at A is negative 24.01 over 0.85 times 9.81. So this is our pressure head, plus 3.820 squared over 2 times 9.81. This is our velocity head, plus negative 1.200. Again, this is our elevation head. So as you can see in the figure, can you see distance niya from the datum line. Also negative siya. Therefore, the energy at A is negative 3.336 meters. Any questions? Okay ra? I hope na-gets na, no? So again, we have here pressure head, the velocity head, can you see that? We get the velocity, 3.82, and then we have the elevation head. So mura na siya, class. Now, if you solve different problems also, you can encounter different types of setups. So, naiuban nga setup nga na-pump, na turbine, no, etc. Nga line positive figures. So, ang keywords lang diri is, kani siya, vacuum of 180 mm of mercury. So, when you say vacuum, this is extracted, no? So, negative na siya, 180 mm of energy. So, when you say added, ato na siyang i-plus. Okay? So, do you have any questions? Last call.
Ngano ganing negative 1.2 na sir? Wala ko kakuan.
Based atong reference datum siya, nam din itong 1.2 at A man ta.
Okay
So,
sir.
dili negative 1.2. Okay, so mahuwag na minus 1.2 na ni siya. Okay, so if you have no more questions, so muhatag kog assignment, and then I will be asking some of you to present your solutions sa next meeting. So please submit your assignments next meeting, ha? Para these assignments mo serve po niya as your practice problems. Okay? So, next meeting, discuss po tag new topic after na discuss yung assignment, no? Okay, we need to catch up sa mga coverage sa midterms. Okay, so if wala na question, then we can go. So, goodbye
Sir.
everyone. Sige, sa ma'am.
Pwede ma-file na, sir?
Dili na ko muhatag. Sorry kayo.
Sige.
No, kay actually na-notice na ko nga mo nang uban magsalig lang and ana dili mag-copy of notes. So please pag-effort na mo copy of notes. Okay? Sige, mora na siya. So if wala na tayo questions everyone, then we can go. So goodbye and thank you.
Thank you sir.
Bye, sir. Thank you.